Okay, today we're learning about surface area of a pyramid, and remember the surface area of a solid would be the sum or the total of all of the areas of all the faces added up. In a regular pyramid, the base would be a regular polygon, so it could be an equilateral triangular pyramid or it could be a square pyramid, and today we're going to focus on the square pyramids. The slant height is notated by this cursive L, like that, slant height. That is going to give you the height of the triangular face on the pyramid. So you can kind of see that notated right here. They've taken and basically kind of cut this pyramid right down and rolled it out flat. Here's the measure of the height of one of the triangular bases. We know that the base of the triangle is S, so each one of these has an area of S times L divided by 2, and there are 4 of them. So you can do that. You can multiply the area of one face, take it times 4, or you can kind of use this concept that these would roll out flat, and this would be the base and now the height of a parallelogram, but because the shaded triangular part is only half of that, that lateral area would be equal to half of the area. So we're going to add up all the areas. We're not going to focus so much on the formula, but I want you to be aware that there is a formula for the surface area of pyramids. So the base is a regular polygon, we talked about that, and then we have 4 congruent isosceles triangles. The diagram shows the square pyramid. The blue dashed line L is the slant height of the pyramid, and it's called the distance from the vertex to the midpoint of the edge of the base. We would look at that and describe it as the height of the triangular face. So here's that formula I was talking about. No need to copy it down, just kind of be aware that there is a formula, and I will show you how to use it. However, we're going to focus on just the concept of surface area being the sum total of all the area of all the faces. Okay, so to work this one out, I will look at the pyramid, and the first thing I'm going to start with is, we'll go ahead and start with this capital B. We know what the capital B is, right? Capital B is the area of the base. In this case, it's a square, so 9 times 9 is 81 meters squared. And then I need to get the area of this triangular face and know that there are 4 congruent triangles. So we have the area of the triangle being equal to 1/2 of our base times our height, okay? And our lateral area will be 4 times that. So the lateral area is that area of all 4 of the triangular bases. So actually I'm going to rename this and call this our lateral area of our pyramid, because we're going to go ahead and take that times 4 right away and get 180 meters squared. So that came from the area of the triangle being 45, and then 45 times 4 is 180. So that our surface area is the area of the base plus the lateral area, which is 180, or equal to 261 meters squared. Okay? Now let's look at it using the formula. Okay? If you take your base, which is the length times width, or a square, and then you substitute in the perimeter of the base, which is 9 times 4, times the lateral height, or the slant height, you get the same thing, 81 plus 180. Let's try another. In this case, we want to take the area of the base, which is 49 millimeters squared, and then to get that lateral area, we want to take the triangular face right here with a base of 7 and a slant height of 12, right? That's the height of that triangle, to take 1/2 of 7 times 12 and then times that by 4. So when you take 7 times 12, you get 84. Divide that by 2, you get 42. Times that by 4, you get 168. And that's millimeters squared. And if you add those together, we should get 217 millimeters squared for the total surface area of this pyramid. To use the formula, right, which takes the area of the base times that lateral height, it's just doing the same thing, but for the lateral height, it's taking that perimeter of the base, because it's kind of like laying out those triangles flat and making a parallelogram, but then taking half of the parallelogram to get that lateral area of 168. So again, the total surface area is 217 millimeters squared.